All right, the video I have for you today is all about factoring a special case of special factoring called difference of squares. So it's all the same thinking. It's just there's a pattern here that is worth recognizing as unique. And so I'm going to bring back a card from one of our last videos. It's where we were distributing two binomials that were exactly the same. So x and 5 and 5, they were the same in element, but they had opposite signs in there. And so what we found when we did the distribution is we had, excuse me, x times x is x squared. We created these other terms along with it, a negative 5x, a positive 5x, and a negative 25. And what we saw was when we combined like terms, these were opposites. So a negative 5 plus a 5 zeroes out, and so they disappear. And our final answer was x squared minus 25. And so what we saw was that middle term was gone. And I believe at the end of that video I said something to the effect of, notice this is a perfect square, this is x times x, and 25 comes from a perfect square product that is 5 times 5. And the subtraction, sometimes we use the word difference. And so this is a difference of squares right here. And so what we're going to see today in this video is, what if you're given two terms and told to factor? Well, we're just going to go in the backwards direction and we're going to get something like this as our final answer. Okay, so here's one where it is still three terms, just to show that we have two numbers we need to find that will multiply to negative 9 and add to 0. So when we go to factor, we're still creating space for two binomials. The first term always gets factored into the first positions of these parenthesis groupings. We're looking for two numbers that are the same. So 3 and 3 work because 3 and 3 make a 9. And 3 and 3, if signs are opposite, will add to 0. That's why we want two numbers here that are the same. And so we need them to multiply to negative 9. So one of these has to be positive and one of them has to be negative. I could have made this negative and that positive. That won't matter. But notice what happens if I go to distribute. I'll get a positive 3x. I'll get a negative 3x. They will add to 0. So this is a factored form of this equation here. So here's one where this is how you're most likely going to see them, not as three terms, but as two. And so we have x squared minus 9. And so you're still going to prepare, even though there's only two terms, you're still going to prepare a binomial space twice. So the first position, you take the square root of it, right? We factor that, it's x and x. And the factors of 9, we're looking for identical factors. So we're looking for the square root is 3 and 3. And then because there's no middle term listed, we get to assume it is 0 x's that the middle terms add to. So we have to create that, and we're multiplying to a negative, so we know we have one positive, one negative. So this is really how you're going to see them as two terms. Notice it's x times x is x squared, negative 3x, which add to 0, so it's not represented here, and 3 times negative 3 is negative 9. So this is factored form of difference of squares. Here's another one. We'll go rapid fire now. So here's two binomials. You're going to notice a pattern. Square root the first term, square root the last term. Give them opposite signs. You can only jump to this pattern here as long as you understand that we're trying to multiply to a negative 36 and add to a 0. Notice 6x minus 6x will make that 0 for us. This is factored. Now, for those who might encounter a challenge or desire a challenge, you can do this where there's a coefficient other than 1 in front of the x squared, only if this number is also a perfect square. So I have a 4 there. So the pattern is still the same. We're still square rooting the first term, so we need two numbers that multiply to 4 that are exactly the same, because even this has to be the same. So that's 2 and 2. And then the x and x we're familiar with. And then we ask ourselves what two numbers multiply to 25 that are the same, or you could ask yourself what's the square root of 25, and that is 5. And in order for these to not yield a middle term, we need them to cancel, so one's positive and one's negative. And that is how you factor a difference of squares.